All right. So, hope everybody had a good weekend. A couple things happening this week. On Friday, we're going to have ourselves our next quiz over graphing sine and cosine. It'd be a good way to end the week. Your first exam is coming up next Thursday on the 21st. Look for it to have law of sines, law of cosines, the ambiguous case, side-side angle, also the formulas for finding the area of two oblique triangles, Heron's formula, and then the side angle side one. We got a fire drill coming up on Friday the 15th during fourth period. And I mentioned just a moment ago that on Wednesday of this week, during third period again, the juniors are going to have a meeting probably in the dining hall, but the email wasn't specific about that, so I'm sure Mr. Anderson will tell us. All right, so let's go ahead and get going. Well, we've been talking about what we refer to as sinusoidal functions. These are transformations of the sine graph. Okay, well, we've got this form here, a times sine of bx plus or minus c plus or minus d. Okay, well, a, my leading coefficient, is going to help me with the amplitude. This is found by using the absolute value of a, and it's the height of our wave. It's half the total height of your graph. Okay, b is the coefficient of x, and that's used to help me find the period. This is the number of radians needed horizontally before the graph repeats itself. Okay, both sine and cosine have a period of 2 pi because that is one revolution around the unit circle. Once you get past 2 pi, well, then you're dealing with coterminal angles. So the y values, the output remains the same. That's why the graph just repeats itself over and over again. We find the period by using 2 pi divided by b. That was our formula for that. Then, did we get to this last week?
Yeah.
So we did get the first one done. Okay, all right. So I'm not going to worry about the second one here. These are, pretty basic problems. The one thing I do want to go ahead and bring up, when you're looking at a horizontal transformation, remember those are always trickier than the y's, the vertical. If you're looking for a horizontal dilation, remember the key word here is reciprocal. All right, I took the reciprocal of 2, which is 1/2, which is why the graph of 4a horizontally compressed or shrunk. Okay, over here, when you add or subtract to x directly, the key word is opposite. Okay, now I'm still going to go ahead and run through that strategy I introduced last week, not because on a problem like this it's really needed, but it is useful on those larger transformation problems that we're going to take a look at in just a few moments. So, because it says sine of x minus pi, what direction is this going to be shifted, left or right? It'd be right, yeah, because it says minus, it's going to be shifted right pi units. Now remember, a phase shift is just a change in name only. This is still just a horizontal shift or horizontal translation. Just with trig functions, we refer to it as a phase shift. Now, if you were to go ahead and take a look at 5b, which I'm not going to worry about, the notes online have that. The phase shift is pi. So we have x minus pi and x plus pi. So the formula we're going to use in order to find that is c divided by b. Now c is whatever you add or subtract from x. Now one thing I am going to go ahead and point out, some of the problems on your homework, they replaced x excuse me, with theta. So whether you have theta or x in there as a variable, that changes nothing. Don't let that bother you. Okay, so if I were to come back over here to the problem we worked last week, we can see b is the coefficient of x. Well, I see that b is equal to 1. C is the value that I'm subtracting. So if I apply it to this formula, pi divided by 1, well, there's pi. That was the phase shift. Okay, very, very simple formula. All right, and then down here, it doesn't mention it by word. It just goes ahead and brings up the idea of the opposite. When we have bx minus c, shifts it to the right. When we have bx plus c, it's going to shift it to the left. Okay. And then I want to go ahead and just do one more problem, and we'll go ahead and just spend the rest of our time looking at the assignment. Okay. Okay. Oh, all done?
I don't know what my calculator is doing.
Okay. If you'll put it in the tray, ma'am, I'll take care of it for you. Okay, the last thing we're going to look at is the midline. So this is our vertical shift. If you add or subtract a number from the entire equation, you can shift a trig graph up or down. This is a shift in the x-axis, which creates a new midline for the graph. Okay, so basically it's just shifting the x-axis. It's the exact center horizontally of your function. I always want to go ahead and label these with an equation. So this first one right here, because it says plus 1, I know that this is just a vertical shift up 1. So the midline here would be y equals 1. We always want to list the midline as an equation, just y equals. So over here on 6b, cosine of x minus 2, every point on the graph is going to shift down 2 units, including this midline. I believe it's in the auditorium, okay, but don't quote me on that. Okay, thank you. Have a good one. All right. Now, let me go ahead and kind of step back for just a second. Let's say that I had just given you these problems without it being part of a section that says it's a vertical shift, and I said I just want you to go ahead and sketch these for me. How would you know these are vertical shifts and not something done horizontally? Okay, well, we know they're not directly affecting x because is there something missing? There's no what? Parentheses. Parentheses is going to be key on these. Okay, typically anything done outside the parentheses is going to be a vertical transformation. So with there being no parentheses here, I can't say that that's directly connected to x. I say it's just adding to the function itself, sine of x. Same thing over here, cosine of x minus 2. Okay, well, which one would you like to work? Okay, 6a or 6b? Which one looks better for you? 6b, okay. Now let's go ahead and start with the pre-image. Remember that was the parent function that we were getting in the habit of sketching last week. Now remember cosine started with a maximum, then had a what? 0, then a minimum, 0, and a max. So remember cosine had that period that looked kind of like that curvy V. And we have enough room here. I can go ahead and continue this for a little bit longer. Okay. There we go. This is the pre-image, cosine of x. Now remember, the image is the final transformed graph. We're going to draw it as a solid curve. Now here, we don't really need to go ahead and use that strategy. I'll go ahead and bring that up in just a second. Every one of these points, including the midline, is just going to shift down 2. So this point right here is down 2. This point's down 2, and I'm just going to go straight down the line. Okay. Okay, so that now when I connect them with the smooth curve, there we go. That would be cosine of x and then minus 2. Okay. So this is an example. A would equal 1. B would equal 1. C would equal 0. There is no phase shift here. And then D would equal negative 2. And typically D is what's going to be used to represent this vertical shift. So that's easy, right? Nothing to it? Okay. You guys want to do 6A or it's pretty much the same thing? Same thing? Okay. The only thing I do want to go ahead and mention before we get to one of those bigger transformations is remember those key points for cosine and sine, particularly the y values. Remember, cosine started with a max, then a 0, minimum, 0, and then ended with a maximum. Now, sine, on the other hand, sine started with a 0, then went to a max, 0, minimum, and then back to a 0 again. We're going to be using these in our transformations in just a minute. Okay, so why don't we go ahead, because this is what I was hoping. I was looking for quite a bit of time on the assignment. Let's take a look at a problem on the homework. Okay, now we can do one of two things. I can either let you guys go ahead and choose a problem you'd like to work together, or I could just go ahead and tell you what both first and second period chose to work on. What would you guys like? Jordan, what do you think? Okay, they chose problem number 12. Okay, problem number 12. So they chose one that had a lot of transformations. Is that one okay for you guys? Okay. Now, here's the thing. They've already done one thing for you. What I mentioned earlier, instead of x, they replaced it with theta. Again, that changes nothing. If you want to go ahead and replace it back with x, completely up to you, whatever you like to see. But they did go ahead and factor out that coefficient of theta for you, that value of b. All right, so I can tell immediately, because this coefficient on theta is now 1, I know that this guy has a phase shift of 1 left. Remember, when we add or subtract from the variable, we always take the opposite. Okay. Now, what I would go ahead and encourage you to do, especially since we're learning about these ideas over here, I'd probably go ahead and multiply that back through. So -3 cosine of pi over 3 theta plus pi over 3, and then we have the -2. But you don't have to. If you feel comfortable leaving it apart, absolutely, go ahead. Because this is my A, this is the B value, this is the C, and this is the D. Okay, so we have all 4 of the values here, so we have quite a bit of transformations going on. Okay, well, let's run down the list, and then we'll go ahead and start to put this guy together. The amplitude. What was the formula for finding the amplitude? Oh, now, that's for something else, and it's close. C over B is the phase shift. Well, what do I do to A? There you go. The amplitude is the absolute value of A. Well, because A equals -3, well, the absolute value of -3 is 3. So each wave should have a height of 3 units. Now, overall, the graph should have a height of 6. Okay. So now the period, Philip, what is that? What was the formula for the period? Ooh, no. Okay. Now that's the phase shift. It does involve B, the period. So there's something up top divided by B. What's a period for sine and cosine? You don't know the period? Okay. Well, why does the graph repeat itself? What's one full revolution on the unit circle? 2 pi. Okay, so the period is found by taking 2 pi and dividing it by b. Now, if I go back over here to my function, I see that b is pi over 3. So I'm going to say 2 pi divided by pi over 3. Okay, well, what do I do if I divide by a fraction? There we go. So 2 pi over 1 times 3 over pi. Well, it looks to me like those pi's are going to cancel, so my period should be what? Looks like 6. And see, that's also another reason I wanted to go ahead and copy the homework for you this time, because each of the grids given is specific to the function you're asked to sketch. I thought it would just make it easier, and more people would be willing to go ahead and work the assignment if they already had the grids ready for them. Okay. Now, Philip, what's the formula for the phase shift? C over B. All right. C over B. Okay, well, in this case, I can see that C is pi over 3. I'm going to divide that by the coefficient B, which is also pi over 3. But what's anything divided by itself? 1. See, what they did originally for number 12, they factored the coefficient of B out, so they were giving you the phase shift directly. Okay, so you only want to look at the value of C if that B coefficient has been multiplied through. Otherwise, you don't need to worry about the formula. Okay, either of you have any questions about that? Okay. And then what helps me find the midline, A, B, C, or D? It's D. So we're subtracting 2, but the midline, we always want to write it as what? We always want to write it as y equals. We want the equation. So y equals -2. Okay, good. Now, here's the thing. This horizontal axis is still in radians, even though none of them are in terms of pi. So we have 2 radians, 4 radians, 6 radians. Would you like me to go ahead and draw the original graph before we get started, the pre-image? Nobody wants to see that, especially since we don't have pi? Okay. All right. If you do, just change your mind. Let me know. So where would the midline be again? Y equals what? -2. So I'm going to go ahead and draw this. Okay. So that takes care of the midline. Now, what I want to go ahead and do is use the strategy I introduced last week to find 5 ordered pairs on one period of this function. So the first thing I'm going to do is take my horizontal transformations, everything in the parentheses, and I'm going to create a compound inequality. So I'm going to say less than or equal to pi over 3 theta plus pi over 3 less than or equal to. What am I going to put the horizontal transformations between? What did we do last week? There you go. I'm going to put it between 0 and 2 pi. Because remember, for whether it's cosine or sine you're trying to sketch, each of them has a period of 2 pi radians. So we're always going to start this way with the horizontal transformations. Let me give myself a little more room. Well, now I want to isolate theta. So the first thing, I'm going to subtract pi over 3 from each of the 3 parts. Okay. I'm going to save myself some room here. So 0 minus pi over 3 is a negative pi over 3. Less than or equal to pi over 3 theta. Less than or equal to, what's 2 pi minus pi over 3? 5 pi over 3. There we go. And we're almost there, but I need theta by himself. What do I do? There you go. We could divide through by that coefficient, or as Philip suggested, just go ahead and multiply by the reciprocal. All right, well, those are going to cancel. Those are going to cancel. So it looks like my lower boundary is going to be what? -1. Less than or equal to pi over 3 and 3 over pi are going to cancel, so there's my theta. Less than or equal to 5. Okay. So this confirms what we found previously. How far a distance is it from -1 to 5? 6. And isn't that what we originally said the period was going to be? So as you go through, you should be able to see little bits like that confirming that you're correct. Okay, so I'm going to go ahead and put these x's to the side. We're going to go ahead and figure out what the y values need to be, and then we're going to pair them up. So right now, these are the x's, but I'm not going to complete them yet. Okay, let's go to the y values. Now, because this is cosine, we said just a moment ago, it starts with a maximum. Then it has a 0, a minimum, 0, and ends with a maximum, right? Well, what's happening vertically? Or is there anything happening vertically on this one? Okay, so there are 3 transformations. First, the entire graph is shifting down 2. That's one. What's another one? Ooh, now that's horizontal. What are the other 2 transformations? So everything's being pulled down 2 units. What's the function itself multiplied by? So -3. Remember, we've already taken care of the horizontal. The only thing we have left is the -2 and the -3. Okay, so what's the negative's job? He's going to reflect it, so he's going to flip it, right? With the x or the y-axis? X-axis, so he's going to reflect it with respect to the x-axis. Okay. Now, if theta or x itself had been negative, then it would reflect with the y. Okay. What's that 3 going to do? Because remember, we don't want to look at that as -3. We know the negative is a reflection. Okay. Well, it's not a vertical shift, a vertical stretch, a vertical expansion. Okay. So anything happening vertically, that is always going to apply to these y values. So each of these 5 numbers right here, basically I want to do 2 things. I want to take the y's, I want to multiply them by -3, and then I want to subtract 2. Let me go ahead and put the dot here because I don't want people to think that's an x. So I want to take the y values and multiply them by -3 and then subtract 2. So let's start with the first one. What's 1 times -3 minus 2? negative 5. Okay. Now, because I have another 1 at the very end, I know he's going to be a negative 5 as well. Now, let's go to the 0. 0 times negative 3 minus 2. Negative 2. So this is a negative 2. This is a negative 2. And now there's 1 left. Negative 1 times negative 3 minus 2. That would be a positive 1. Okay, so these are the y values that I need. Okay, the 3 vertical transformations are going to do this to them. Okay, so now that I've got my y's, I've got my x's, I'm going to take these and I'm going to pair them up. Remember, you always take your lower boundary and you pair it with the very first y value. So I'm going to put this negative 1 right here. You're going to take the upper boundary from your compound inequality, and you're always going to pair it with the last y value. So I'm going to go ahead and put the 5 right here. Now immediately, without even finishing it, this gives you 2 ordered pairs. I've got one ordered pair, negative 1, comma, negative 5, and then I've got another one, 5, comma, negative 5. Okay, so let's go ahead and plot those on the grid. Let me get rid of this here. Let's see, negative 1, negative 5 would be right here. 5, negative 5 would be right here. Okay, let me go ahead and erase this. Okay, so between these 2 dots horizontally that I just put, I should see 1 period of the graph. Okay, how do I find these missing x's right here for my other 3 ordered pairs? There you go. Remember, these 5 points each have 4 horizontal distances that are always congruent. Okay, now we are going to divide by 4, but what am I going to divide by 4 in this case? Not pi. 6. Remember, you take the upper boundary and you subtract the lower boundary. So 5 minus negative 1 is 6, and you always, always, always divide that by 4. But what is 6/4? 3 halves. So this is what I'm going to be adding over and over again in order to get those other ordered pairs. Okay, so let's start with the lower boundary. What's negative 1 plus 3 halves? So think a negative 1 plus 1.5. It would just be 1 half, right? 0.5. Now do it again. What's 1 half plus 3 halves? One half plus 3 halves. How many halves would that be? 4 halves. But what's 4 divided by 2? It's 2. Okay, now what's 2 plus 3 halves? 3.5, so that would be 7 halves. Okay, and let's see, will 3.5 plus 1.5 give me 5? Remember, it should always match up exactly with your upper boundary. Okay, so do any of you folks have a question on where I got any of those values? Jordan, we okay? All right. So see, now I've given myself 3 additional ordered pairs. I know the next one has to be at 1 half negative 2. So 1 half negative 2. Then we have 2 comma 1. And then we have 7 halves or 3.5 negative 2. There you go. That's 1 period with 5 exact points off that transform function. Yes, sir. Uh-huh. That's actually a good point. I'm glad you brought that up. For the phase shift, I would just go ahead and give the distance as it is, like in this case 1. But I would probably go ahead and put some kind of indication of direction. So you could say left or use an arrow. Okay. But because it's a distance, I would go ahead and write it as a positive. That's a good question. Now, that's 1 period. What if I wanted maybe to fill in as much of this grid as I could? How would I know where the other points are?
Just half, 3/2.
Yeah, basically you're exactly right. Because here's this one point, here's this point, there's the 3/2 distance between them. So all I really need to do is basically just 1.5 units. So the next one would be a 0. And then another 1.5 units. The next one should be a maximum. Okay, so if I start working left, go another 1.5. So it'd be right here. It would be a 0. So you're probably going to get something that looks like this. There you go. That is -3 cosine of pi over 3 theta plus pi over 3 minus 2. There you go. So see, like I said last week, that strategy, it organizes everything for you. It gives you 5 exact points for one period on the graph. I'd say that one right there is probably the toughest problem on the assignment. All right, we still got over 10 minutes. Good. Where would you like to go from here? Or would you just like me to turn you loose and let you kind of work on your own? What would you guys prefer? Philip, you just want to work on your own? Kaushal? He doesn't care. Jordan?
Doesn't matter to me.
So you guys don't want to work another problem? All right. If you do have a question, let me know. We have a quiz over this on Friday. The assignment is due when? Tomorrow. So when we come in, we'll take our happy minutes. We'll go ahead, talk about whatever questions you have on the assignment, and we'll go ahead and get started with graphing tangent. The assignment's due tomorrow. Yes, sir.